Okay, our second lesson won't be as daunting as the first one. Okay, so second one, we're starting on functions. So we're going to look at function notation, domain, and range today. A function is a set of a domain which follows rules to get to a range. So every element in the domain maps to an element in the range. The set of all domain is a set of all inputs. That's the domain. And the R is a set of all outputs, which is a range. Okay, function notation. Y equals not f times x, but f of x. Okay? So we have to find the value of the function at x. So whatever the x value is, we put it into the function to determine the y value. X is the independent variable, y is a dependent variable. Okay? So x is the domain, y is the range. So every member of the domain maps to a member of the range. Two different domains can map to the same range. It's like a checkout at a supermarket, the self-checkout. You can scroll items past it. Every item has a price. Can two different items have the same price? Absolutely, two different items can have the same price, but every item has a price. Here, when you scroll the first item past, it has two different prices. Does that make sense? No. So this is not a function because you can have one member of the domain go to two different ranges. If a domain goes to two different ranges, it's not a function. Okay? It's not a function. So, examples of a function. This is a function. This is a function. This is not a function. How can we tell that something is not a function just by looking at the graph? Yeah, somebody remembers their algebra 2. The vertical line test. If you draw a vertical line anywhere through the function and it hits the function at more than one spot, then it's not a function. So it's just a relation. So if you draw a vertical line and it hits the graph more than once, okay, it's a relation, not a function. So the vertical line test defines y as a function of x if and only if no vertical lines intersected at more than one point. Unless we are dealing with a model that necessitates a restricted domain, we'll assume the domain is defined for all real numbers. Okay? But there are certain problems where the domain is restricted. Whenever you have a radical, the domain is restricted. Whenever you have a variable in the denominator, the domain is restricted. Okay? So finding the domain of this one. Now, the square roots cannot be negative. Thank you. So this has to be greater than or equal to 0. Okay? So then we'll square both sides. So x plus 2 has to be greater than or equal to 0. So x has to be greater than or equal to negative 2. Okay? So the domain of the function, it includes a negative 2, and it goes all the way up to infinity. What do you call this format? Something notation. Interval notation. Interval notation. So, when you take college algebra, some of you have already done with it, maybe? Or are you guys all Has anybody in here taken college algebra yet? No, no, no. So when you take college algebra, you'll do a lot of writing stuff in interval notation, so we'll practice it a lot here. Okay? Interval notation. All right. When a variable is in the denominator, what cannot be in the denominator? You can't have the denominator equaling 0. So x cannot equal 0. So what's interval notation for this? We start at negative infinity and we go up to 0. But we cannot include 0, so it's going to be a parenthesis, not a bracket. Bracket includes, parenthesis, not includes. Doesn't include 0, and then we're going to have a union, and it's going to go from 0 to infinity. So negative infinity to 0 in union with 0 to infinity. That's the range of this function. Oh, the range. Oops, I found the domain. So this is the domain. Now we need to find the range. What values happen for this? Well, I would graph it out. 2 divided by x. Well, 2 divided by 0, we can't. 2 divided by 1 is 2. 2 divided by 2 is 1. 2 divided by 3 is 2/3. It goes like this. Okay? If we try negative numbers, 2 divided by negative 1 is negative 2. 2 divided by negative 2 is negative 1. 2 divided by negative 3 is negative 2/3. Goes like this. So what's the range? Well, the range goes from negative infinity all the way up to here, which is 0. So the range goes from negative infinity to 0, and it also goes from 0 up to infinity. It happens to be the same as the domain for this one. Okay, just by the way the graph is. The domain is negative infinity all the way up to 0. Can't do 0. And it's from 0 all the way up to infinity. Okay? So that's the range. So it's generally easiest if you look at a graph to find the range. And that's what they did. All right. And continuity is on Tuesday. So I will put your assignment out there. And this assignment will be better than your last assignment. Last assignment is kind of hard. So, escape. That's what I want to do. Escape. Discard. Here. Stop.